Hey, how's it going, Math9 students? Mr. Tronis here. I hope you had a great weekend. The sun was shining, so I hope you got outside and collected a little vitamin D. Um, I just have it on the screen right now showing kind of what changed last week. I gave a catch-up week. After talking with a number of students, a lot of you are right on pace, which is great. But even those that were keeping up with everything were feeling many were feeling overwhelmed with their other classes, and I thought it prudent to give a catch up week because this has been a bit of a learning curve for everybody. So you can see here the updated version that this was a catch up week. I am not going to be doing 4.1, 4.2. Reason being, long story short, they're about developing equations from patterns, and it is not detrimental that you know how to do that. It's not crucial, I should say, that you know how to do that moving into grade 10. You will get plenty of practice doing that, turning word problems into equations. You'll do that in grade 10, whether you take workplace math or foundations pre-cal. So it's not something that I would say that you're missing out on. So I thought, you know what? Talking to a couple different grade 9 teachers, they're doing the same thing. So it made sense to give a catch-up week. Many of you have got all your assignments in now, and you're starting with kind of a fresh, clean slate, which is great. This should be 4.3 comes first, so that should be in front. There we go. And so we're going to be starting with 4.3. Now, a little bit of review. I'm going to start off this stuff with this chapter is linear relations. Everything we're doing has to do with, well, linear, you can think line. So just to kind of blast back to where we're at right now, if you have not done it yet, please get your week 4 self-assessment in. Report cards have been put into my ed, so you can see your grade there, but I also will be sending emails home in the next 24 hours to your families and how you're doing with term 3 technically of the year. So it'll have your grade, and that is mostly based on before spring break and kind of this first chapter. It doesn't even include all of the chapter we did online, but I will be mentioning, how far you are with your assignments if you're behind, just so your family and you kind of have a reminder. We only have 6 weeks till school's done. This week, the Zoom meeting is mandatory. I will be putting out multiple reminders, so I apologize for that, but I need everybody there to talk about a number of things. So please get your week 4 self-assessment in. If you haven't yet, please, there's a number of you that have not submitted the math talk yet. This was due on May 8th. So please try to get this in. I'm recording this on Sunday, so you can do this. Trust me, if you need help, I'm here to help. But moving forward, I'm going to start 4.3. But to start 4.3, I need to talk about this thing. Okay, you've seen this plenty of times before. The big fancy word for this is the Cartesian plane, named after somebody famous, but who cares about that? Let's be honest. It's a graph, okay? And it talks about 2 things that can change. The left and right, okay, can change, and we call that the x-axis. Okay, axis, namely being the straight line, horizontal, and then up and down can change. Okay, and we're living in a 2D, 2 dimensions, and this is, of course, the y-axis. Okay, now I know this is review, but that's the point, and I need you to be able to graph coordinates. Normally in class, I would give you a quick little warm-up assignment where you'd graph a whole bunch of coordinates and would draw some type of picture. I'm not doing that. Okay, if you don't have a printer, you're going to want to get good at drawing these with a quick ruler, okay, and just use the centimeters to mark it off. So if you set up a ruler, let me just move this. If you set up like a ruler, I don't know if can you see the ruler on your screen? I hope you can, but if you set up a ruler here, and what you do is, can I rotate? Oh, there we go. Just got to use my roller. You set it up like this, and then you can draw a straight line and just mark, normal gaps, usually maybe like a centimeter each from like negative -10 to +10, so about 20 marks, okay, is like the max you would need. Usually a graph like going up to 6 in each direction is good too. But yeah, just utilize that, and you're gonna have to make your own graphs if you don't have a printer, which is okay. Okay, so I need to get rid of this ruler. There we go. Okay, and let's zoom in again. So what you need to be able to do is graph coordinates. Well, what's a coordinate? Well, we always go alphabetically. So a coordinate is written in parentheses, fancy word for brackets, although people can generally, bracket actually means the square brackets. But so parentheses, we have an X and a Y alphabetically. So our X value is the first number and our Y value is the second number. And if you move on to 3 dimensions way later on in grade 12 or in university, you'll have a Z value. And that's your 3rd dimension, which is how you do 3D animation and whatnot in computers. But what are we talking about here? So if I gave you the coordinate 1, 2, what does that mean? You have to go start at 0 is how I like to count these, and I do my X first. I go over to the right 1, and then I look at my Y. So you don't have to draw these bunny hops, but I'll show them. Like kind of a little jump. I move to 1, and then the Y is 2, so I go up 2. So it's right there. Okay? The other way that some students do it, say you had the coordinate -2, -3. Some would go to the X, okay, and they would then draw a line down, kind of a dotted line, and then they would go to the -3 and draw a dotted line and see where they meet. That's the other way of doing that, okay? Whoops. So these are all called coordinates, okay? And you need to be able to graph them. And just, you're not always going to get whole numbers. You might get -3.5 and 4. Okay, so -3.5, you kind of estimate it to be right about here in between -3 and -4. And you go all the way up to 4, moving across, and you draw your point there. So it doesn't always perfectly land on your whole numbers. And you can handle that. That's no problem. So that's a review of the Cartesian plane of your graph of X, Y. And that's as far as we're going to go with that right now. Okay, so you need to know how to do that, how to graph points. And you would have learned that back in grade 7, maybe 6 for some of you. So let's dive into our notes here. So 4.3, let me just change the view here. I apologize if this first set of notes is a little bit longer than some. Just want to make sure we start off on the right foot. So yes, we are in 4.3, but don't worry, you don't need 4.1 or 2 to be able to do 4.3. Okay, it does say recall that we can make a table of values to make a graph of a linear relation, and all that means is in 4.1, 4.2, you did stuff like I just showed on the screen, where you can have values that are set up like this. This is a table of values where X is on the left and Y is on the right. This is a table of values, sometimes called a T-chart. Okay, and you can put in values like 0, 1, 2, and 3. And then you have values for Y, I don't know, maybe like -2, -1, 0, and 1, for example. Okay, and then you could graph these points. You put brackets here, right? Parentheses, and you could put your commas in between, right? And then you could graph all those points. So how do we do it over here? It's asking you to graph the following, and we have an equation, y equals 3x minus 1. Remember, an equation means left equals right. Everything on the right equals the left. But one way to think of this is like x is the input. Okay, so I'm going to put in a value for x, and I'm going to get an output of a y value. Okay, and you'll learn more about that in grade 10. That's called function notation. But for now, we're going to make a quick table of values. So step 1, we are going to make a table of values. Okay, so how do we do that? Pretty simple. We just make this kind of T-chart, this graph, and we put our x on the left and our y on the right. And our x is 0, Why am I choosing 0? Because 0 is easy. It makes the math really easy. And then I'm going to choose 1, and then I'm going to choose -1. You only need 2 points to make a line, but it's always recommended to do 3 values, because if you mess up on one of them, you'll know. You can self-mark, and your dots, your coordinates will not line up in a straight line. So I usually go 0, 1, -1. Okay, there's times when you're going to choose different numbers, and we'll talk about that, but we're choosing the easiest numbers, and generally these are pretty simple. Well, what does y equal? Y equals that whole thing, 3x minus 1, which is equal to 3x minus 1. So we have to do what's called substitution. So now we substitute these values of x into our equation to find y. Okay, so what that means, let's show it really clearly. I'm going to use a couple different colors. I go 3, and then I substitute an x for 0. So I go 3, and I'll quickly change to blue, 0, okay, minus 1. And what does that equal? Well, we quickly do some BEDMAS. 3 times 0 is 0. Okay, multiplication first. Subtract 1 leaves us with -1. Same thing again, 3, and this time we substitute. I'm just going to get the next one ready, so I don't have to change colors too many times. 3 times +1 this time, and the next one's going to be -1, just to go a little bit ahead there. -1, -1. So now we've set up, each time we're substituting the x value in to find y, okay? Because y is equal to that whole thing. So now I put in 1, so 3 times 1 is 3. So we get 3 subtract 1, and then we do the subtraction, which is 2. And 3 times -1 is -3 minus 1, which is equal to -4. So now here are my coordinates, 0, -1, 1 and 2, and -1 and -4. So let me make that really clear. I'm just going to draw a couple. And these are my coord. That's short for coordinates. So I get 0, -1, 1 and 2, and -1, -4. Now I'm showing a lot of work right now. Many of you could just basically make a quick t-table and do a lot of the basic BEDMAS in your head and get your 3 coordinates and graph them. That's fine. You don't have to show all these steps, but I'm trying to show you everything that happens here. Okay. So our first coordinate is 0, -1. So it's at x is 0, y is -1, draw a dot. 1 and 2, x is 1, up 2 to y, and -1, -4. So to the -1 and down 4. Now, if you look at that, they line up. And now that I have 3 dots, they line up. I know I did it correctly. I can draw the straightest line I can freehand. You use a ruler. I cannot put a ruler on my screen. There you go. Pretty good. So that's my line. So what we did again, sorry, I probably should have written what the next steps were there. But step 1 was make a table of values. And then step 2, we graphed our points. And then step 3 was, maybe I'll underline these. Step 3, we draw the line. Just draw a line. Okay, that's all we got to do. All right, so couple special cases coming up before we move on here. Okay, x is equal to 4. Now we look at this and we're like, okay, well, how do I do a table of values? This is a special case, so I'm just going to write special case because there's no y. Special case. And I want you to think of it like this. I want you to say, and I'll put it in quotes, x is always 4. Okay? X is always 4. What line can you draw on that graph over here where the X value, no matter where you are in the line, is always 4? So another way of thinking of it, if I draw a t-chart and I put X and I put Y, and X is always 4. So let's just draw 3 points. And Y, you wonder, okay, well, what do I put for Y? Well, if X is always 4, it doesn't matter what I put for Y. Let's put 0, 2, and negative 4. Doesn't matter what I put for Y. So then now there's my coordinates. So I go 1, 2, 3, 4. I draw a point at 4, 0. I draw a point at 4, 2. And I draw a point at 4, comma, negative 4, which is down here. And you can see the special case that we get is a vertical line. So I'll try to draw this straight. So we get a vertical line going through X equals negative 4. So a vertical line through X equals 4. Okay, that's all. It looks simple, but these questions slip up students all the time where they say, okay, well, there's no Y. What do I substitute? I don't get it. It's just a special case where X is always 4, which is a vertical line. So I don't think I need to say a whole bunch to repeat everything over again, but this is Y is equal to negative 3. So again, special case where Y is always negative 3. And what line does that? Well, you guessed it. I hope you guessed it. If you haven't, think about it. If my Y is always negative 3, it does not matter what I put for X. So 0, 1, negative 1. Let's do that. So if it's negative 3 for my Y, 0 for my X, 1 for my X, negative 1 for my X. So we get a special case of a horizontal line. Oh dear. Sorry. Try to keep that straight. Okay. So we get a special case of a horizontal line. All right. So what have we done so far? We did a table of values, substituted in those values, okay? And then got our coordinates. Moving down, we had 2 special cases, the vertical line and the horizontal line, okay? It's when X is equal to something, it is always that value, so it must be vertical. And because no matter where I go on that line, my X is always positive 4. And no matter where I go on this horizontal line, my Y is always negative 3. All right, so if the equation, we'll move on to a couple more examples here. If the equation doesn't already have the Y variable by itself, rearrange it so that it does, okay? This will make your table of values easier to create. So notice it is not solved for Y right now, okay? It makes it way easier to solve it for Y. And you're not going to get very complicated questions in grade 9 where the algebra is too advanced. We're going to do a lot more of that in chapter 6. But this here, whoops, we want to solve for Y. And that's just fancy for AKA get Y on one side of the equation. Okay, so I'm looking at this and I'm saying, okay, yeah, sure, I could move the Y, okay, but it looks like it's easier because we learned this before. We got 2 terms. We got a 2x term and a y term. Why don't I just get that 2x term onto the other side of the equation? So this is a big thing from grade 6, 7, and 8 math, but you need to be able to know that you can manipulate equations. That's called algebra. You can take things and move them over and do opposite operations like subtracting, adding, multiplying, dividing, that sort of thing. So first step is solve for Y. And this can be a little bit of algebra. So we have 2x plus y is equal to 3. And I'll show you a technique. You don't have to do it this way, but lots of times students lose track of the left side and the right side of an equation. What you can do is draw a dotted line, okay? And that just helps you keep track of where the equal sign is. So now I want y by itself. Well, it's pretty close. It's just got this 2x term over here. So if you're adding the 2x there, let's subtract it. Okay, this is a positive 2. We don't write the positive, but it's a positive 2x. So we can subtract 2x from the left. But if we do that to the left, in order to honor this equal sign, we have to subtract 2x over here. Okay, we have to. So what that then creates is a couple things. On the left, we achieved our goal. The 2x minus 2x is 0, so it's gone. So all I have left on the left is y. Now on the right, I have now 3. Now I cannot, these are not like terms, right? We know that 3 is a constant and this is a single degree term, okay, with a coefficient and a variable, okay? These are not like terms. I cannot go 3 subtract 2. So I have to keep them apart. They are 2 different terms. And I want you to get used to, and you could do this all in one step, but I'm showing you in 2, is that you put the x term first. So the coefficient's -2, and I move the +3, -2x plus 3 to the right. So all I did here was I took each term, and we've seen this before, I took this term and I moved it, I'm going to try and move it here, and I took this term, including the sign, and I moved it to the in front. That's all. Okay. So now that I've done that, I can do a table of values. So let's just, actually, I think I can fit it right here. So we'll go 2. Step 2, table of values. Okay, T for short. So what do we get? I'm going to draw it a little bit bigger just so you can see all the work. X, again, I'm going to choose really easy numbers like 0, 1, and -1. Keep it really small, keep the math easy. And then over here, I have y, which I know is equal to -2x plus 3. So now I substitute in 0 into this equation. So I have -2. I'm just going to keep it all one color here. 0 plus 3. And then -2, 1 plus 3. And -2, -1 plus 3. So each time I just took the x value and substituted it into the equation. And now I'll do some quick bed mass. -2 times 0 is 0. That's why we chose 0. It makes it easy. Plus 3 is 3. -2 times 1 is -2, or -2 times 1, yeah, is -2. Plus 3 gives me 1. And -2 times -1 is +2 plus 3 gives me 5. Okay? And feel free to use a calculator for that. If you're mixing up your negatives, you just got to remember your basic integer and your BEDMAS rules for these equations. They're not very complicated. So now I have 0, 3 is my coordinate. So step 3, graph points or graph coordinates means the same thing. So we have 0 up 3, draw a point, and 1 and 1, draw a point, and -1 and up 5, 1, 2, 3, 4, 5, draw a point. There we go. And let's finish it off with a line. Try to go straight as I can and draw it all the way through it, arrows at each end indicating this line keeps going. Okay, it is not a line segment. We could have put in any value for x. We could put in 100 for x, -100, whatever, but this line keeps going. Okay, I didn't say that before. So the arrows, because line continues. We just chose those points, okay? But we could have done any point on that line. There's infinite points, actually. Okay, we're going to do one more with slightly, this is as hard as it's going to get algebraic. It's going to be 2 steps to solve this one for y. So again, step 1, solve for y. So we have our equation, which is 3x minus 2y equals 6. Lots of ways to get y by itself, mainly 2, but I generally just leave the y term alone, okay? I'm going to just leave that one on the left because I want to get y all by itself. So I'm just going to leave it be at the beginning. So first you need to, the strategy is actually doing reverse BEDMAS. Okay, and reverse BEDMAS means I'm going to subtract this 3x first. Instead of dealing with this -2 times y multiplying, we're going to deal with the addition of this term first. Okay, so what I'm getting at is isolate the y term first. There's a lot of ways to teach algebra. So that's why it's great if you're struggling with this stuff to work with me one-on-one. But what we do is we subtract 3x. Oh, I forgot that one strategy I like to do is you can draw your line going down. So I'm going to subtract the 3x over here, okay? And what that then gives us is the 3x is gone on the left. And then we rewrite our equation is -2y is equal to, and I'm going to put it in front, plus 6, okay? Notice what I did here. That was a plus 6 minus 3x. I can't put them together, okay? So I moved it over. I moved the 6 over, okay? So it was 6 subtract 3x, but I can just switch the order of these terms. Now, and that's coming from chapter 5, so you should know how to do that. Now we have the y. It's almost by itself. It's being multiplied by -2. So this is what I mean reverse BEDMAS. Now we do the reverse of multiplying. First we did the subtraction of a term, and now we're going to do the reverse multiplication. So we're going to divide by whatever's multiplying the y. We want to reverse it. So we want to reverse it by dividing by -2. So then we have to divide by -2 over here. And you divide the whole side by -2. All right? So 2's are gone. They cancel. -2 divided by -2 is 1. And 1 times y is just y. Okay? Now over here, I'm going to break it down even further. So I have -3x over -2, and this is from last chapter, and plus 6 divided by -2. And that's then equal to, I have a double negative here. So I'm just going to change that to a positive. You don't have to, but it's kind of a common practice. And then plus 6 divided by -2 is now going to be subtract 3, because 6 divided by 2 is 3. And the sign change due to the negative. Now I have it solved for y, and we can put in a table of values. Again, I was saying this is as hard as it gets, this question. Okay, we had to do 2-step algebra. We did 2 steps. We subtracted the 3x, then divided by the -2. And now we have our equation. Okay, now the table of values, I'm still going to choose x equals 0. But then I'm going to make a specific choice because I'm looking at this equation and I'm thinking, I don't like that fraction. Okay, I don't like this fraction of 3 over 2 minus 3. So whatever number I put in for x, it's going to be multiplied by 3 over 2. Well, here's a quick strategy that I highly recommend, making your life way easier, is put in values for x that are multiples of the denominator, okay? And you'll see what happens here. So if I chose 1, okay? If I chose 1, let me just put it in over here. Don't write this down if you are writing the notes, but I'm going to put it in green. If I chose x equals 1, then I'd have y is equal to 3 over 2 times 1 minus 3. And that equals 3 over 2 minus 3. And then now you have to do subtraction of fractions. And if I recall from that chapter, most of you didn't really like fractions a lot, because then you'd have to turn this fraction into times 2 times 2. So you'd get a 6, and 3 subtract 6 would give me negative 3 over 2. And now I have a fraction for my y. My y equals negative 3 over 2, which is pretty hard to graph. So I want whole numbers. So if I choose a number, so I'm going to write it here, choose multiples of denom, which is equal to 2 in this case. So I'm going to choose 2, and I could go negative 2, by the way. Why not? Let's do that. And negative 2. All right. So now I have 0 is always a good choice. Okay, because now we know we have 3 over 2 times 0 minus 3. Well, 3 over 2, yeah, it's a fraction, but times 0 is 0. Subtract 3, we get negative 3. In our next one here, we have 3 over 2 times 2. Subtract 3. Well, 3 divided by 2 and then multiplied by 2, the 2's cancel, right? If you divide by 2 and multiply 2, you just reversed what you're doing. 2 divided by 2 is 1. So 2 divided by the 2, you cross cancel that, and it's gone. So now you just have 3 subtract 3. And we're left with 0. Okay? And this last one is, again, 3 over 2 times negative 2 this time. Okay, minus 3. So now the negative 2 divided by the negative 2 gives me negative 1. So that's going to give me negative 1 times 3. So we get negative 3. Okay, rewind this part. If you're not following what I'm doing, rewind it and listen again. Negative 3 is what I get here. Okay, now I get, and subtract 3 gives me negative 6. Okay, so here's my coordinates, 0, negative 3. Well, 0, negative 3 on my graph is 1, 2, 3. I draw a point. There's my first point. 2 and 0. 1, 2, and 0 for y. So it's right on my x-axis. And negative 2, negative 6. 1, 2, 1, 2, 3, 4, 5, 6. There it is. All right. So now I can draw my line. It's still, oops. There, now is it red? No, I'm still green. Go red. There we go. Oops, that's not a very good line. And there we go. Okay, I don't know where that red square came from. Okay, that is as hard as it gets. So sorry, 3, my steps are in circles. Step 3 is draw points. I did 2 and 1. Draw points and line. Okay, and if all 3 line up, you know you did it right. If they're not lining up in a straight line, something's wrong. So I will say B here is as hard as it gets in this chapter. So first we had to do a 2-step to solve for y. Then our table of values, we had to do some sneaky choices of our x's to make the fractions go away. Now I'm going to be showing you in the next lesson a way easier way. You still have to solve for y, but then you don't have to do any of step 2 here. Okay? I'll show you an entirely different step. It's called y equals mx plus b. It's called slope-intercept form. And you're going to, every time I teach it, students prefer it by far. All right, so your lesson is attached to this Google Doc. Get going on it. Get trying it. Please email me if you have questions. It is tough to start with this one, okay? So make sure you are, there's lots of YouTubes out there on how to graph a line too, so don't, how to do a table of values, things like that. But please ask questions, okay? You can do this. I believe in you, and I hope you're doing well. For now, that's it. That's all.